In this next section, we're going to take a look at transforming functions from a table. A function f of x is given in the table. Create a table of values for g of x equal to the opposite of f of x, and h of x equal to f of negative x. So let's take a look at g of x first. So g of x is simply the opposite of f of x. So for example, if f of x is negative 1, then g of x is going to be negative 1. If f of x is 5, then g of x is going to be the opposite of 5. Similarly, if f of x is 3, g of x is the opposite of 3. And if f of x is 9, g of x is the opposite of 9. So g of x was a pretty easy function. Let's take a look, though, at h of x. So h of x is equal to f of negative x. Notice that in our table, we have x equal to 2, but we don't know what f of negative 2 is. We're not given any values for it in the table. And so you might wonder, well, how can we find values for h of x? Well, remember from the last video that we just watched that when we multiply the input by a negative number, we know that h of x is going to be a reflection of f of x about the y-axis. And so it'll help us, I think, to draw a picture of what that's going to look like. So here's our y-axis here. And so, for example, f of x has the point 2, 1 on the graph of f of x. So h of x would take this point and reflect it about the y-axis. So we would have this point here. And what would the coordinates at that point be? That point would be the point where the y variable is equal to 2. So this is the point negative 2, 1. So if f of x, if we input 2, then our output is also going to be 1. Let's take a look at another example. What would f of 4 be equal to? Well, f of 4 is equal to 5, and so let's think about where that's going to be in our picture. All right, so our original function has the point 4, 5. So 4, 5 might be something like this. Here's 4, 5. Now what would h of x be? H of x is the reflection of this point about the y-axis. And if we reflect this point about the y-axis, it will come over here. And what would those coordinates be? Those coordinates would be negative 4, 5. And so the output variable is still going to be 5. You can do the same thing for 6 and for 8, but essentially what's going to happen is that this original point will be reflected over the y-axis, and so the y-coordinate will stay the same. And so the output variable for each of these is going to be the same as the original output variable. I know this gets a little tricky when we do tables, so let's look at a few more examples. A function f of x is given in the table. Create a table for the function g of x is equal to 1/2 x, f of x. All right, so let's take a look. So here's our original data. And what we would like to do is we would like to create a new function. All right, so let's see how we might go about doing that. Well, if x is 2, then if we put a 2 here, g of x would be the same as f of 1/2 times 2, or in other words, the same as f of 1. if we look at our original data, we don't know what f of 1 is, and so we wouldn't be able to find that value. Let's try another example. What if x was 4? What if we put in a 4 for x? Then g of x would be equal to f of 1/2 times 4. Well, that would be the same as f of 2. And what is f of 2? From our table, we can see that f of 2 is equal to 1. So if our input is a 4, our output is a 1 in function g. So we can fill that in. If our input is a 4, our output will be a 1. Let's try another one. Well, if we have, let's try putting in a 6. What would g of 6 be equal to? Well, if we put in a 6 for x, that would be f of 1/2 times 6, or in other words, f of 3. Notice in our original table, we don't know what f of 3 is, so we won't be able to find g of 6. Let's see if we can find g of 8. G of 8 would be the same as f of 1/2 times 8. In other words, the same as f of 4. And we can see that, oh, we do have a value for that. We know that f of 4 is equal to 3. So if we plug in an 8, we'll get an output value of 3. So what we're noticing is that from our table, we can't find a value for g of x for every x we'd like to put in, only certain ones. Let's see if we can go a little more. All right, so let's see, could we find 10? Well, if we wanted to find g of 10, we would have to be able to find f of 1/2 of 10, or in other words, f of 5, which is not in our table. What about g of 12? G of 12 would be the same as f of 1/2 of 12, or in other words, f of 6. F of 6 is in our table, and so we can find that value is 7. So if we put in a 12, our output is a 7. Now looking at a pattern here, if we look at the x values for which we were able to find outputs, 4, 8, 12, you might guess what you think the next value we'll be able to find is. So if you're looking at this pattern, 4, 8, 12, you might guess that we might be able to find what the output value if we plug in x equals 16. Let's try. So g of 16 would be the same as f of 1/2 of 16. That would be the same as f of 8. And yes, that's the last value we have in our table. And so that output would be 11. One more example. A function f of x is given in the table. Create a table of values for g of x is equal to 2 times f of 3x plus 1. All right, so let's give this a try. So the first x value we see in our table for f is 6. Let's see if we would be able to find a g value for x equals 6. Well, g of 6 would be equal to 2 times f of 3 times 6 plus 1. Well, this would be the same as f of 18. And let's see if we have a value for f of 18. Oh, we do. So f of 18 we can see is 15. So this would be 2 times 15 plus 1, or in other words, 31. So if we put in a 6, our output is 31. Let's see what other values we might be able to find. You might wonder, well, what if we tried to do g of 12? In order to do g of 12, notice that we have to be able to do this value right here, which is f of 3 times 12, or in other words, f of 36. And notice that there is no 36 in our original table of values, so we would not be able to find this. And so the question becomes, What values of x could we find values for g? Well, we have to be able to find f of 3x. So the only values that we can find g is if we know a value for 3 times x. So if we look at our table of values, here, 6 is the same as 3 times 2, 12 is the same as 3 times 4, 18 is the same as 3 times 6, and 24 is the same as 3 times 8. So notice that we were able to find a g value when x was 6. I think that leads us to think that we should try these other values for x and then see if we can find the value for g. So what we're going to do is we're going to see in our table if we can plug in 2, 4, we already did 6, and then see if we can do 8. And again, the reason we're trying this is because we can only find values where we know 3 times x. And if we look at the initial values, we wrote these as all multiples of 3, this one being 3 times 2, 3 times 4, 3 times 6, 3 times 8. So let's see what happens if we give that a try. All right, so let's see if we plug in a 2. Then g of 2 would be the same as 2 times f of 3 times 2 plus 1. Well, this is f of 6. And we know what f of 6 is. F of 6, according to our table, is 10. So we have 2 times 10 plus 1, in other words, 21. Let's try the next one, g of 4. G of 4 would be the same as 2 times f of 3 times 4 plus 1. That would be f of 12. And we can see from our table that f of 12 is 14. So that's 2 times 14 plus 1, or in other words, 29. And finally, our last one, 8. G of 8 would be the same as 2 times f of 3 times 8 plus 1. F of 3 times 8 would be f of 24. And we can see from our table that f of 24 is 17. And so we have 2 times 17 plus 1, or in other words, 35. And so that's how we can find transformations from tables. So why don't you try a few before we go on to our last topic?